Before my kids got smarter than me, we used to enjoy this thing called camping. Now, I'm not talking about glamping, where you do all the fun things and you bring the refrigerator along. We actually did camping. We would get in a tent. We would go out to some remote place without cell service. My wife specifically chose it for that reason, I think. Probably because certain people wouldn't get off their devices. But we would go to these remote places and we would kind of just enjoy being with each other, but also being outdoors. And it was a great respite. I particularly enjoyed it. As my kids got older and smarter than me, they realized Dad's boring and we don't want to do that with him anymore. But the other thing that happened is exactly what Rod just talked about. The world got digital. So now you don't actually, let me grab this. You don't actually have to go fight through poison oak. You don't have to go get on those lumpy inflator beds. You can simply grab your Quest goggles. You can hop on your Peloton. You can get yourself in your bedroom on the second level and actually enjoy an immersive digital epic that will take you right through my campground without ever leaving your home. And somebody has captured all of that and put it in a digital world for you to enjoy. These aren't actually really Quest glasses. I'm sure you all figured that out. I'm Charles Anyimi with Solidigm, and I want to share with you some of the reality points behind the story that Roger just led with. What are some of the actual customer examples that we are experiencing, the benefits that customers are seeing utilizing this dense storage that we refer to as QLC or 4 bits per cell SSDs. So one of the things that Roger led off with was the fact that you have this opportunity to rapidly access more data more efficiently. Now, Taboola, you may not know of, but if you've ever gotten financial insights at Bloomberg or looked on your phone and gotten information from the Weather Channel about how to dress today because of the potential elements that you might find yourself in, or even if you got your news from NBC News, you've used Taboola's recommendation engine. They claim to be the world's largest content discovery platform. What they do is they source a bunch of your data and my data. And whenever you go to these sites, they use their algorithm to create what they call signals. And these signals are all of the various parameters and attributes that you and I will use when we move our mouse on the screen to say, I'm going to select that. No, I'm not going to select. I'm going to go over here. And they collect all of that information, and then they use that to match content that might actually be appealing to us as a user. And they do this for every single user that comes to a particular site. They process 100 terabytes of data a day. To put that in context, because like Roger, numbers kind of get a bit wacky for me when they get too big. So I'm a science guy, and so I went and looked up how much data the Large Hadron Collider in Geneva generates in a day. It's 120 petabytes a day. This 17-mile loop that is trying to smash particles to figure out the fundamental particles and elements that led to the creation of our universe generates in a day just a little more than the same amount of information that Taboola processes to figure out what you like. So they can put out cat pictures because you're that guy. or whatever it is that you like.
Excuse me, I have a question at this point.
Yes.
So, well, it's clear that QLC is, a very great media, but we have QLC from everybody now. All the other vendors that produce flash memory, 3D, whatever, they have, what is the differentiator of Solidigm? I mean, so where are we going with all of this? Because I listen to all of what you say, but it is a very general QLC pitch. And we heard about it, when QLC was introduced several years ago, was still not even available. I can buy QLC now on Amazon. So, what makes Solidigm different from all the other QLC vendors?
Terrific question. You look at everybody else produced. By the way, there are not a whole lot of other people. It's Micron, Samsung, and Solidigm. That's it. So there are 3 vendors that make it. And if you go look at what they're producing, by far, Solidigm produces the vast majority of the QLC that is consumed and sold in the market today. One, almost 100% of our client SSDs are based on QLC. That is why you can find them on Amazon, because those client SSDs, like the one we launched last week, the P41, 41, 44? Yes, the Pro. P40 Pro. The thing that Roger said, right? That product is 100% QLC, and it is ridiculously fast. And if you are a gamer, that product is like eye candy that you just got to get your hands on, right? But let me get back to your question. The differentiation is to do it at scale and to do it such that you can use it for applications like this. I invite you to go compare our QLC specifications with those of our competitors. You will find that not all QLCs are created equal. Our fundamental differentiation with regard to our floating gate technology and the fact that we combine that with our manufacturing stacking, multiple layers, which other people have as well. So I'm not saying that that in itself is unique, but is the combination of our floating gate technology plus our manufacturing that allows our QLC to be both higher performance relative to reads, particularly sequential reads and random read functionality, and still be large capacity, which you want from a QLC, and still be reliable, because you're still at that point smashing 16 states of information into a 1-cell location. And you have to be able to do that reliably. And that's where I think you'll find some of the other suppliers don't do as good of a job. They still have some room to improve and work to do there. So I invite you to go look at that. But our differentiation is the fact that we can deliver all 3 of those things with our QLC SSDs.
Where are they manufactured?
So our fab is in China, in Dalian, and our assembly test is in Taiwan. But a lot of the design, actually we have, as Roger mentioned, we have 20 locations around the world. So the design is done in a variety of different places. Software, for example, is done in Colorado and also in Poland. So Taboola, to get back to this example, they're trying to figure out a recommendation engine. What is it that you are going to like and be more likely to click on when that information shows up on the screen? And they process 100 petabytes of data in a day, almost the same amount as the Large Hadron Collider, to make that recommendation, to create that inference. And what they are doing is they have what they call a distributed HCI environment. Because they want to keep all the information together, they chose to use an HCI. So their compute, network, and storage in a given server is unified, which also means that it's virtual. And they have multiple of these in a given server, and then they have this distributed across data centers. They have 9 data centers around the world. And so what you end up with is, if they go with a traditional SSD, or traditional HDD, they end up with, oh, a drive failed. Now I have to find it. It's in a virtual pool distributed in HCI within a given data center and then virtualized, so shared across 9 data centers. how do I find the one that is causing me this grief? That was the biggest challenge. So they were actually trying to find more reliable storage. We worked with them, and what we were able to do was to get them to use QLC drives to actually achieve exactly what they wanted to do. And in this, utilizing our 5316, the same ones that Roger referenced earlier when he talked about the CDN example, right, they were able to actually reduce the amount of maintenance cycles they have to do because they were no longer using HDDs. And two, because they were virtualizing in an HCI environment, the drives were so consistent in their behavior and performance, they actually were able to reduce the labor costs required to maintain and upkeep the systems. And three, yes, they were able to process that amount of data much more efficiently, to Roger's earlier point, because they reduced the amount of drives they needed. Because the drives, again, in this particular application, most of what they want to do is read the information out.
So let me get this straight.
Yes.
You're actually saying that you were firing storage admins because this stuff was so reliable.
They reduced the number. I didn't say that. You said that.
No, I'm the person who's all about firing storage admins.
You said that. Go there. That's your business. I said they reduced their labor requirement to maintain their servers.
So Charles, I have another question.
Yes, please.
It's very interesting because I personally, when SSDs came out and I was working at Hitachi, melted an SSD with an extremely high IO workload, right? So we were doing intense, small, read-write types of workloads.
Mm-hmm.
So far, from everything that I'm seeing here, what's interesting to me is that it looks like it's write it once and read it a bazillion times, to use your...
Sure. Yep.
So just curious, because I've been out of the storage game in the sales side for a long time now, has this workload changed to be much more towards the or the use of solid state drives, much more towards the CERN model, if you will, or the big accelerator, where you're grabbing maybe larger chunks of data, but then it stays there essentially forever, and you're using the SSDs to provide really fast random or sequential reads.
That is a lot of what's happening. And
Okay.
I'll tie it back to something Roger talked about, data-rich services. Right. As all of that is happening, as our appetite to be creators and also sharers, we like to discover and share. Cute cat, look. Right? So as we get more and more into that, it becomes less about the core and more about how close it can get to you and how quickly you can do that.
Right.
So those data services are doing that. But don't misunderstand. I'm not saying, and we're not saying QLC is the panacea for everything.
Mm-hmm.
Right? That is not the message. In fact, QLC, the other thing that is making it really take off is the fact that we have distributed computing becoming a very big part of how we all engage the digital world, right? You go from Amazon in 2006 introduced S3 simple storage services as an object store as a way of revolutionizing how we all store data. Previously, it was all block and file, right? And they came up with this, and other people have innovated on it. Red Hat added Ceph to it, and now Ceph can do all three of those things in one. So the advent of object storage, where you now just want to write data, and then you just feed it to people. And if you want to update the data, you don't go update it. You just write another one and kill that instance, and you keep going. That artifact is what's really driving what you're referring to. The fact that now more data is being created. I don't have to worry about the old one. I'll just make another one. That's what's really driving it. So when you think about it, QLC is really a superior and well designed and suited for object store type applications. Right? You could use it for some block things, but block has a slightly different requirement relative to read-write I/O performance consistency. Databases, right? You don't want to be able to delete a database and object, and it says, give me a minute, I'm working on that. That'll never fly. Right? So it's not the answer for everything.
Right.
But in the majority of the cases, particularly in a distributed computing environment like we find ourselves in, whether you Alibaba, Amazon, Azure, make your cloud Cloudflare. There's all kinds of companies out there that are doing infrastructure as a service.
Right.
All of those types of things from an object perspective are really well tuned for an application use like QLC SSD.
So, question. So in order, this is probably a good example of where something like this makes sense. There are other vendors out there that are producing, NAND, QLC, and stuff that are putting computation on the drive, right? Distributed things like this. It seems like a computational storage might have made sense in a distributed HCI environment.
Yes.
I still question that term, but
That's what they call it.
A hyper-diverged infrastructure, right? Yeah. But are you guys working on anything about that? It's great that you have the media, right? But obviously, and you're one of the main suppliers into other people's stuff. And maybe for all I know, you're providing the QLC for those other people making the computation storage. You can tell me about that. I don't know. But what's your attitude on that, on computational storage? Are you working on things like that, and where do you see that going?
Yeah, we are absolutely working on computational storage because you can tell, to Roger's earlier point, as you go from core to mid-tier to mid-tier to mid-tier to edge, you want to process the data at the source as quickly as you can and then send it back for the aggregation. And so from that perspective, what you end up having is you need that computational capability. And right now, we are starting to recognize and add to that body of knowledge by creating computational storage. So we haven't done it yet. I can't tell you all the things that we are doing with it, but we are working on that space. And you're correct. There are suppliers out there, competitors to ours, who have come out with something where they've got maybe an FPGA slapped in front of an SSD, and they're calling it a computational storage box. We like to get deep with our stuff before we come out with it. So we're going to take a little bit more time to make sure we're doing exactly the right thing that we think our customers want.
So, there's one thing I'd love to hear. It's about, what are you doing to kind of differentiate against other, QLC manufacturer suppliers? Are you helping, for example, the vendors you work with to use some unique features that you have to kind of better integrate your QLC drives with their solution, for example, to implement better durability and things of that kind?
I am so
Great to
glad.
talk about that.
I am so glad you asked that question. Let me show you my next example because I will use that to answer your question. They didn't give us permission to use their name, so we will call them a US-based cloud service provider. This particular customer that we worked with was using HDDs to actually drive a Ceph object storage solution that they offer. And they were actually fine. If you know anything about Ceph, you probably know that it doesn't necessarily require the biggest amount of performance, right? Because Ceph underneath is actually is based around a block understanding, but because they have Rados or LibreDos, they are able to do object and things as well. But performance is not their big thing. What Ceph gives you, which is really cool, is something called strong consistency, right? Where they actually can guarantee that when you send them information, it will be replicated on all the clients before you get acknowledged. So that means your data is secure. It provides a great deal of security, and which is why it makes it, for this particular US-based CSP, a really good solution for them to offer to the market. And they were having great success. Unfortunately for them, as their solution offerings, because it is a cloud offering, was being consumed, they were running into issues with the complexity of just managing their data center with that many HDDs. As Roger mentioned earlier, weight, cabling, routing, updating, and not to mention, because they're running a hosting environment for other people to use, the amount of power they were generating with all those HDDs, and therefore the commensurate amount of cooling required. So you can see here that they were using about 90 SATA drives, SATA HDD drives, 7200 RPM drives, and about 90 HDDs in a wide chassis. Now, that's just for one dense solution. They have obviously multiple of these in a given server. And what we were able to do was to take them from all of that 90 wide chassis HDDs to a single 2U. This is where I get to bring in the question that my friend asked a moment ago. So in this particular case, this US-based CSP was able to take their 90 HDDs and reduce that down to 24 drives in a single 2U. Consider the power savings. Let's start with that one. All right. Typical HDD is what? 18 watts, 15 watts, somewhere in there. QLC SSDs, PCIe Gen 3, 25 watts. But you don't need 90 of them to get to the same level of capacity and the same level of performance. So they actually cut their power requirement almost 5x. They cut their space requirements. They don't need wide chassis to hold those 90 HDDs. They went to a single 2U. They built in instant headroom. Their data center now runs a lot cooler. These are the kinds of things that we work with our customers to do because we recognize that QLC in and of itself is a wonderful innovation, but it's best when it's actually consumed.
Ask you a question from a technical perspective. You know, companies that you work with, like Vast, do some very innovative things in reducing power in how their aggregate array is done. They shut components off. Is Solidigm doing anything? Actually, one of the things we learned from Vast is that the vast amount of, pardon me, the majority of power in an SSD is consumed when you do writes, not when you're doing reads. So are you guys doing anything to work on making writes themselves more power efficient to reduce it? So can you elaborate on that at all?
Absolutely. So from a drive, and Yu Yang will cover some of this in her section, so you can feel free to add to it as well. But from a drive perspective, when we make a QLC drive, there was a question asked earlier about why do you need both charge trap and floating gate? And Roger gave a really nice answer to delineate those two things. If you want to go small and fast, charge trap is great. If you want to go big and fast enough, floating gate is the best bet. So when we make floating gate, our very first consideration is power. It's going to get bigger. At a cell level, I don't have to carry. The reason why we use like the large block sizes, we don't have to lay out sense amps and cells at every single cell. So that means less power. I can charge one node and it'll get 16 layers of data.
Okay.
Right. So as we make the die bigger, it actually consumes less power.
On a per byte.
On a per byte basis.
Yeah.
Right. So our last generation of QLC, our largest single die capacity was, I think, under a terabyte. In the 4th gen, Yu Yang will talk about it. It's actually a terabyte. Right. So even just going from 512 to a terabyte at a die level, and then you put that into a multi-stack, multi-package die. Again, because of just the way we design it at a device physics level, its first thing it's going to do is reduce the power.
And that's not a feature of other QLC designs.
Other QLCs can do that because if you're doing, let's say, 16 bits in a given cell, you can decide whether you want to use a 4K indirection, which means, for simplicity, every 4K you'll have, let's say, a power tap. Okay? Or you can make a 16K indirection, which says every 16K you have a power tap. Right? So that's a design choice.
Got it.
Right? So depending on what they choose to do, they can have a better response to that. But then again, it comes on also to your NAND technology. How efficient is it? And the more efficient it is, then also the less power it will be. So it's a combination of both of those things.
So one more thing I just want to add to what Charles said is at the product level, we also added a power level configuration. So customer can change based on their maximum power consumption. It could be 10 watts, 12 watts, or 15 watts. So they can limit the maximum power so that, in the data center, they have more flexibility to
So
choose.
they trade off between performance and power?
Yeah, exactly.
They can choose, though. That's
Exactly.
how much power, how much performance do you need, right?
Exactly.
That's
Yeah.
excellent. Thank you.
And sorry, does it mean that, so because it's not clear for me, the floating gate versus the, charge trap, so how they work together. I mean, so I'm missing something here.
So
So
they can work together, but let's start with them as separate. From a technology perspective, the physics of charge trap is such that you tunnel through. Well, let me not go there because I don't know if that's necessarily relevant. At the end of the day, the way that is designed, it doesn't lend itself to large capacity. So if you want to, if I can simplify it this way, if you want smaller capacity at an appropriate cost, let's call it that, that is high performance, because when you put smaller die, you're able to have your NAND channels be operating concurrently, and so you'll get a much better performance in that sense. And so because of that, charge trap devices tend to be really well suited for small capacity, high performance applications. Floating gate, on the other hand, is predominantly designed for making efficiencies as your die gets larger. So it's going to be better suited for larger capacity applications. The trade-off you make there is you give up on some of your performance relative to particularly writes, but not on your reads, which is why it's nice for applications like object store.
And ML specifically.
AI, ML, exactly. Absolutely.
yeah, but you told us at the beginning, or maybe at this point I didn't get it right, that you have both of them in the same product, right?
Oh, no, we have both of them in the same company.
Oh, wow.
We are the only company that has both of those technologies. Now, don't get ahead of us in our R&D now. We are actually looking at that. There is a possibility of what you can do with that, but I'm not going to talk about that today. So you're not going to bait me. Thank you, though. Good try. But yes, that is something that we absolutely have the ability to do, and we are exploring what we can do with that. But we don't have a product that has both technologies in it today.
Okay. Here. Thank you.
Absolutely. I want to get back to the question that was asked about how we are making this a much more appealing product for our customers, and more in the way of how we help them. And I think I will tie this back to the sustainability comment that Roger mentioned, right? In this particular US-based CSP's environment, when they went from when they had their HDD application, they actually had to build a reinforced subfloor because of the weight requirements for all that many drives. They didn't need to do that when they switched to a QLC solution. So that is one incremental benefit they got from this solution that had nothing at all to do with our drive, other than they got an incremental benefit from it. The drives were lighter, they didn't need as many, the requirement to have an infrastructure that was supporting a much heavier load went away. We talked about the power reduction already, so I'm not going to belabor that point, but I do want to talk about the cooling effect. I had a data center operator conversation I heard, and he mentioned something that I'm still running through my mind. He said that we, as storage providers, suppliers, are missing the point when it comes to sustainability. He said it's not about the power, it's about the cooling. I said, okay, tell me more. He went on to talk about the fact that if you have the ability to run your data center 1 degree hotter, it saves you hundreds, not thousands of dollars in cooling requirements. Like I said, I'm still wrapping my head around that. But it seems to me, by having SSDs like our QLC drives that require less power, such that you don't have to cool them or spend the energy to cool them, you can actually run your data center hotter. Now, all your other components and systems in your data center have to be able to tolerate that. So I'm not saying that's the answer, but it definitely bears some additional study and thought, because that may mean that if you actually had zones in your data center or enterprise, you could have in a non-HDI, as we just learned a little bit ago, environment, you could actually have your data in one area, and you actually can run that area or zone hotter because they are able to actually function and generate paltry amounts of power, so you don't have to cool that area as much as any other. I don't know where he's going to go with that. Like I said, we still have to wrap our heads around it, but I felt that it was an interesting one worth mentioning to all of you. The last one I want to hit on the sustainability side is disposal. According to data from Circular Drive Initiative, data centers around the world dispose of something like 22 million drives every year. Just gurgler, landfill material, whether it's shredded or punched through or just tossed. The majority of those are HDDs, which also means they don't have a whole lot of use life left in them. So even the fact that Roger alluded to repurposing, you can't really do that. They're kind of a one and done kind of thing. If you have most SSDs that are deployed today, utilization throughout its life, which generally is anywhere from 3 to 5 years, only about 15 to 25% of the actual endurance in the drive is used. Now, I know you're all going to tell me endurance is key. We need to make sure these drives are reliable. Yep, that's true. And the technology has gotten so good, they are. To the point that most applications, not all, if you're doing mission critical, right, yes, you're going to use up your drive. So I'm not saying everybody is like that. But in aggregate, 15 to 25% of the endurance in the drive at the end of its use life when it gets retired or shredded is still there. So you now have a different opportunity when it comes to end-of-life disposition. You don't necessarily have to landfill. You can give it a second life. Use the sanitized capabilities that are built into most SSDs, including our QLC SSDs, and eradicate any user data that you have on there. Eradicate it. It's gone. It's sanitized. You can use that to drive, I don't know, an up-and-coming country's data farm? I don't know. I'm sure there are way other things you can do with that. If you're into farming from a network perspective, you can use those for that purpose if you so like. Right? But the point is, it gives you an additional option when it comes to disposition of drives at the end of its life. If those 22 million HDDs were actually QLC SSDs, and at the end of, let's say, 5 years from now, all of them needed to be disposed of because they had now bought our latest, greatest, our 5th generation QLC SSDs. Between Amazon, Google, Meta, and Microsoft, what benefit could they create by just repurposing those for a different function than just putting a nail through them and then chucking them in the landfill because they're done with it? That's the kind of options that we are creating for our downstream partners and data center operators with our QLC SSDs. So I hope that gives you a flavor for the question that you asked. If not, please feel free to ask again. I will try to come up with a better answer for you. So these AI workloads do seem to come up a lot. This one is actually for IoT. Some of you may or may not be familiar with Kingsoft. Kingsoft is actually the technology partner for the second largest, maybe it's the third largest, one of those two, consumer electronics provider in China, Xiaomi. And Kingsoft does this really, really cool thing for Xiaomi. They are responsible for their cloud services, so all the things that they host with all their various devices. And Xiaomi makes a lot of consumer electronic devices. But the thing that they really want is they want smart everything on an IoT platform. That's what they're making as their claim to fame. So your Xiaomi smartwatch can be used to talk to your Xiaomi smart thermostat in your home to set the temperature before you get home. And when you get into your car, it can be the digital assistant in your car, and it knows all the restaurants you like to go, and it'll suggest one for you as you get into the car and tell it you're hungry. Or it'll look at your Oura ring on your finger. They don't have a ring, actually, Xiaomi doesn't. But if they did, I'm sure they would put their AI to it and say, you've been giving a presentation for the last 40 minutes. You should get some water. Your hydration level needs to be improved. That's the kind of thing that they're about. They want to connect every appliance on an IoT platform and allow it to be able to basically help you seamlessly go through life. Kingsoft is their partner that actually does all the training. And they have an AI avatar called Xiao AI. And that algorithm, or the set of algorithms that are used for that particular AI training, is the responsibility of Kingsoft. And Kingsoft was using HDDs to do this because Kingsoft is in a part of China where they had significant power and space constraints. And so they couldn't put a lot, but they also wanted to be cost conscious, and so they started out with HDDs. As you heard from Roger, just speech recognition in 3 years went up 17,000x in parameters. When it comes to training AI algorithms, as Xiaomi put out every new consumer electronic device, there was even more data that they need to train the AI on. And so the amount of data they needed to process just ballooned. And the problem became the HDDs couldn't keep up. They actually had to put more in, not for capacity, but to keep up with their phenomenal NVIDIA GPUs that they were using. So we worked with them, talked to them about QLC SSDs, and they found the benefit. They drank the Kool-Aid, and they were able to get a much smaller power footprint. I've already talked enough about that, so that shouldn't surprise you. But they were also able to get optimized performance. Before they did the transition, their GPUs were underutilized. They were using about 40 to 45% of their GPU bandwidth, because the rest of the time it was waiting for data to come. When they made this transition to QLC SSDs, their utilization jumped to north of 75%. And it actually reduced their footprint, so they didn't have to go get more space, which is what their next step was because of all the HD. They couldn't fit any more in there to get any more performance out of the system. Not that it wasn't there, they just couldn't get it out. Now they didn't even need to get any more space. They just instantly built in space, and they were running much lower footprint and lower power. It's those kinds of things. Again, I'm not here to say that this is a panacea for everything, but what I do want you to understand is that real customers are using this technology to attain real benefits that are material for them. And this technology enables that, not because it's set out to say, I'm going to help you save X, Y, and Z, but because of just its inherent design and the way in which it's being applied, customers are realizing massive benefits from utilizing this technology. Before my kids got smarter than me, before I had kids, and I was one, I used to love Speed Racer. I don't know if any of you know about Speed Racer, but it was actually a Japanese anime, and it was brought to the US back in, I think, '67. I watched it in syndication, just to be clear.
Are you Racer X?
I am not Racer X, although I know who Racer X is. But Speed, as he is known, was such a cool character to me. But more than that was the car, the Mach 5. The Mach 5 had cool functions. Actually, it was, the late 60s, early 70s. So the cool functions were the steering wheel had buttons that were labeled A, B, C, D, E, F, G, and H. And that's how speed accessed the additional functions and features of the car. One of them, the F, for example, was a Frogger mode. If you went into water, it would seal him in a cocoon and provide oxygen into the cabin, and he could just drive the car under water. It was like just the coolest thing. Autonomous driving isn't quite yet at Frogger mode, but a lot of the features that were in the Mach 5, you will find in autonomous driving today, right? B was belts. They had tires that would allow it to basically run on any terrain. Many autonomous driving cars today have the ability to use run tires and those kinds of things. Regular combustion engines can also do that as well. They had a feature for, what was A? A was, suspension. You could actually change the suspension of the car, raise and lower it. You can do that today. So let me tell you about InnoNet. InnoNet is an autonomous driving company that basically specializes in data collection and analysis. And what they're trying to do is similar to what my earlier example with 42 dot was doing, which is to process the information that they collect and then to analyze it to give back the useful information to use as training sets. They do use LiDAR, by the way. They're not trying to skip out on that technology. But their environment and infrastructure was one that was being hampered by the amount of data that they could collect in any given time because they were using TLC SSDs. And because the TLC SSDs had a smaller capacity, they had a similar problem to what 42 dot had. They would run for X amount of miles, then they would have to come back and dump the data. And they were not getting the benefit of a normal driving experience to use to train their algorithms. And so similarly, we worked with them utilizing our QLC technology, and we were able to give them a much better solution. They also were running RAID in their particular application, RAID 0 to be exact. The innovation that we helped them with here was, if you look at the box that is to the just above upper left of the Mach 5, I don't know if you can see it, but there is a module in there that has handles. Those handles, it's a removable data storage module. It contains 4 PCIe slots and is populated by QLC SSDs. They can literally put that in, plug it to the car, go drive around, come back, take that module out, put it to the system to download, put another module in, and send the car right back out. So they actually modularized the SSDs and they put it to use to actually do both sides of what they're trying to do, both the data collection side and the data analytics side. So again, just to wrap it up on Roger's points, every one of these examples I've given you hopefully has helped you understand how utilizing QLC SSDs can help you access more data more quickly and more efficiently. But just in case I haven't made my pitch convincing enough, Dell Technologies will be releasing PowerScale featuring QLC SSDs. There's a QR code with a link to their storage review article. David Noy, product leader over at Dell, talks at length about their PowerScale storage solution and how they're able to garner fantastic improvements gen on gen utilizing QLC SSDs. Again, here I invite you to go watch that, look at that, follow up with that, and see what Dell has to say about the benefits they're getting from QLCs.